To remove the connecting rod bolts requires a special wrench. It's a 10mm serrated wrench, and it fits the head of the cap bolt. And I use a 13mm socket in the back, and then a long extension like this. Now the reason for the long extension is so that I can clear the cylinder studs when I use my breaker bar to back the bolt out. Now I'm using a tie-down strap over the top of the engine with a rag under it to protect my newly painted inner timing cover, kind of keep the engine block tight on the bench as I remove the connecting rod bolt. Now I have the end of the connecting rod suspended on the cylinder studs with a little garden wire, and I also used a shop towel along the cylinder bore here just to protect it in case the rod drops. Then I just insert the special wrench into the bolt and connect the breaker bar and back it off. There it goes. So I'll just back it out with the little wrench here. Okay, there's the rod bolt. Now these are designed to stretch when they're torqued, so you can only use them one time. So I've got new bolts. To back out the bottom bolt, I rotated the engine a little bit so it's exposed. And same drill. There it comes. Now the bearing shell is in two pieces, a front piece and a back piece. And I will remove those here in just a second once I get the bolt out. Okay. Now I'd like to get my fingers in behind the shell, so I'm going to rotate the engine just a little more, and then I'm going to see if I can pull the front of the rod out. And sometimes it's not wanting to come, but it's loose. Not quite letting go. Now, as you can see, there's a little bit of a ridge on the back of the back shell half. So I'm going to put a little screwdriver on there and tap to get it to separate from the front shell half. Okay, that did it, and I got the front shell half to come out. And then right here I stuffed my towel a little further in so I could catch the back shell and it wouldn't drop into the engine. And there it is. Now I marked the end with an L because this is the left side, and I also marked the half shell here with an L, the back shell. You'll see there's a pin and two holes, so the shells go together like this around the crank. And then inside is the bearing half shell on each, and in looking at them, they don't look to be damaged or scored badly, so that's a real good sign. I was worried because this bike's been sitting for a while, and it's got 64,000 on it. Now this is the connecting rod journal, and I'll measure the diameter to be sure it's in good condition. So in preparation for measuring the connecting rod journal, I have a set of micrometers that can go to a 10,000th, and the one I'm going to use is the 1 to 2 inch micrometer, and it has a little gauge block that's exactly an inch. And what I want to do is check to see what the calibration is. So I'll hold the gauge block between the anvils, and then I use the little clutch here to tighten it up until the ratchet clicks. And if I look carefully, it's not quite at 0. So if I come over here, this is the vernier that gives me 10,000th, and I'm looking for the line that matches up with one of the little numbers. And it appears to be off by about 2 10,000ths at the moment. And since the 0 on the barrel is below the 0 on the micrometer, that means it's minus 2 10,000ths. That's the difference in length. So I rotated the crank so the journal is in a position that I can get the micrometer on it. And I opened the micrometer up to about 1.9 inches, which is the order of magnitude of the journal diameter. And then I slip it in, and I move it a little up and down as I tighten the clutch to find the tight spot, because that's the measurement point. Okay, the clutch slipped. I press the lock, and then I pull it up off the journal, and then I can read the measurement off the micrometer. Now, to read the micrometer, each of the little tick marks is 0.025 inches, or 25 thousandths. And remember, this is a 1 to 2 inch micrometer, so when it reads 0, it's actually already got an inch. Now, if I look at this, I see there's 3 tick marks exposed past the 8. So I've got 1.875, and also the line here is somewhere in between the 14 and the 15. So I need to add another 0.014 inches to that. And then to get the 10 thousandths, I look at the barrel here, and I look for which number and line is lining up with another tick mark on the barrel. And the 4 is the one that's lining up. So I have 4 10 thousandths that I also have to add in. Now I use a spreadsheet to record the measurements, and I note here which micrometer I used. I also noted what the connecting rod journal dimensions are for acceptable, and that's 1.8888 inches to 1.8894 inches. And for calibration, I note that I need to subtract 2 10 thousandths from all my raw measurements to correct for what I found when I calibrated the micrometer. Now, the spreadsheet adds in the value for the micrometer, which was 1.875 inches, and then I add in how much was on the barrel, 0.014 inches, and then I add in how much was on the vernier, which was 0.1234, or 4 10 thousandths, which gives me a raw value of 1.8894, which I apply the correction to, and gives me the corrected value of 1.8892. And then I average 3 measurements to get the final value. Now, both are at 1.8892, and that's well within the range because the upper limit is 1.8894. So I've really only found about 2 10 thousandths of wear on the connecting rod journals. So they are very, very good condition. To remove the old bearing shells from the connecting rod half, there's a little groove here in the bearing shell and a slot behind it. And I just take a small screwdriver and I stick it back and pry the bearing shell up and then it slides out of the connecting rod. So just do that and you get them loose. This is the set of 4 bearing shell halves that I got from Euromoto Electrics, who've been supplying free parts for this charity rebuild project. So there they are, ready to install in the connecting rod halves. Now, this is the left connecting rod, which I marked with an L. And on the bottom, one face of the rod has the 2 pins that go in the holes on the back shell. And those pins should be facing the front of the engine. So what I've done is I put an arrow on the end of the rod. So when I install it, I'll make sure first I've got the left rod on the left crank journal, and second, this faces to the front of the engine, because I don't want to make a mistake on that. Now I'm ready to install the bearing shell halves into the connecting rods, and each of them has a little raised notch on one end, and that matches the groove. And second, I don't want to get fingerprints on that material because the oils in your finger can corrode the bearing material, so I'm going to wear some gloves. And all I do is just line it up, push down, and snap it in. And then I make sure that the halves end right at the face on the rod. So I've got them in there. Now I want to protect the bearings from being dry when the first engine start occurs. So I'm using some molybdenum engine assembly lube, and I liberally apply that in the bearing shells and make sure I smear it all around. And I'll also put some of that on the crankshaft journal as well. So everything will be lubricated on the first start. So I put a shop towel on the cylinder bore to protect it should I drop the rod. And I put the assembly lube on the crankshaft journal. And also I put some on the cam lobes because I can get to them pretty easy from here. Now, the connecting rod bolts need to be lubricated with 3-in-1 oil liberally before I put them in and torque them. Now, the other thing to remember is that this is the left rod, and the pins are going to be toward the front of the engine. So that's where the arrow is. And that means when I insert the shell in the back, I want the holes to be on this side too. So I'll just slide the back shell in and hold it on there with my finger. And then the front shell, the front rod can come in, and I may need to rotate my crank just a little bit so I can get some clearance. There we go. Now I'll put a rod bolt in and just spin it a little bit to catch the threads. And then I can get the top bolt in a minute. Now I lowered the rod a little so I can get the top bolt in, and I use the special tool to tighten them up and alternate sides so I can pull the rear shell snug to the connecting rod. And I just keep going back and forth until everything's snug. Now, one other thing I like to do as I snug up the rod bolts is I make sure that the connecting rod is moving freely so that I'm not getting any binding. And it's possible to do that if you don't get them tightened up uniformly. So it's just a good idea as you're going forward to just be sure the rod is going to rotate smoothly. Okay, I'm ready to torque up the bolts. So I have my extension on my special wrench, and I'm using a torque wrench set to 36 foot-pounds. And the technique is to smoothly turn this all the way until you get the click. So here we go. Okay, top one's done. And now for the bottom one. Okay, all done. You'll notice I also put my little garden wire to suspend the rod just to keep things from getting out of hand and having it drop onto the engine case.